So continuing on with our introduction to hydrology, we're going to speak a little bit about flooding, land use, and drought in this section, as well as government agencies that help support hydrology-related missions in the United States. First, we're going to review the hydrologic cycle. This should be a general review. We know that the majority of the Earth's surface is ocean and seas. A lot of the rain that we see over land actually is from evaporation from our salt water. Clouds form, it rains, you get the point. Precipitation falls to the ground, it's good for the plants. There are plants that are also in the water, and things like trees, crops, they can also give off water vapor through the form of transpiration. Some water makes it into the soil. There's actually a lot more in the ground than we actually once believed, but where it's at and accessing it continues to become more and more of a problem. So groundwater resources are a slowly renewable resource, but not very rapidly renewable, so we can exhaust those resources quite quickly. Groundwater ultimately connects either to the ocean or to surface water in some cases. Alright, so that's just a little bit on the hydrologic cycle. Should be a review. There are two terms that I mentioned in there, transpiration and evaporation. So transpiration is the one some folks sometimes forget about. That's that water vapor going off from the plants. If you're from eastern Kentucky, you know what transpiration's like because you see in the morning a lot of fog in some cases. A lot of that's from transpiration from all the plants. So trees, and particularly trees, and plants in general, do a good job trapping moisture and keeping moisture as well. So deforestation and those types of things happening around the planet actually take away a lot of the water from the actual surface, and you can have long-term impacts. Aquifers are something that you may have heard of through grade school or different types of education, and I can pull up a image of what I viewed as an aquifer back when I was growing up. So when I was growing up in grade school, science teachers that I had, they kind of talked about the aquifers like they were some sort of underground cavern or cave, and saw like this movie that was Goonies back in the day, and that's what I thought was an aquifer. And aquifers can operate that way, especially like in western Kentucky, like in cave country, you can have that. But in many cases, aquifers actually are more like water that just fills in this porous space. So groundwater gradually seeps into that porous space, from the surface, and it gets to a point where it's trapped, like it can't go down any further. There's like a hard surface, and at that point it follows that hard surface, to the nearest water source in some cases. In some cases it has nowhere to go and it stays trapped there and just continues to pile up towards the surface. The water that actually makes it out to the edge, we call that base flow. So in eastern Kentucky, you'll have droughts that go on for a while, or actually a lot of just Kentucky. You may not have any rain for a while, but yet somehow the creeks and the rivers are still flowing. Well, a lot of that is through these natural seeps and just ways in which groundwater makes its way into these creeks, and we call that base flow. Base flow is those low levels of water in our streams and rivers that are being fueled or fed by groundwater. If we get rid of groundwater's ability to make it in to the ground, if we don't have vegetation, we have a lot of impermeable surfaces, we don't have base flow. The creeks will run dry. So which agencies are responsible for managing and monitoring our nation's water supplies? So a few of the major ones, the National Weather Service provides a lot of rain data, rain gauge data through the National Weather Service, which is part of the National Oceanic and Atmospheric Administration. Also, U.S. Geologic Survey, USGS, which is part of the Department of Interior. They have a lot of the gauging stations. So They make sure that we're able to know how fast the water is coming down the river and how high rivers are. The Army Corps of Engineers, where they're active with regards to flood control lakes and navigation systems, the Army Corps also is very involved in monitoring precipitation as well as the flow of water. So all these agencies have some responsibilities for helping our nation model water for like agriculture and irrigation, and for navigation and transportation, for flood control, and for also managing water releases so that we can have water for drinking water treatment as well as water to support wastewater treatment, and water also to support aquatic life. In the United States, where do we get the most amount of rain? And the Pacific Northwest actually has enough rainfall to where they consistently get more than 90 inches of rainfall. They're a temperate rainforest, so it's not a tropical rainforest, it's a temperate zone. Tropics are down here. This is a temperate rainforest, so they get enough rain that they're actually a rainforest. Periodically, here in southwest North Carolina, northeast Georgia, in some years they get enough rain to be a rainforest, and occasionally every now and then Kentucky does. But to be a rainforest, you have to have consistent rain over a long period of time, over 40, 80 years or so, to become a true rainforest. And maybe, if the rains keep up and the trees are there, you might have that in the southeast. It depends. Climate is changing quite rapidly. So this area in the southwest North Carolina, just south of the Smoky Mountains region, actually all this is kind of the edge of the Smoky Mountains, in the Blue Ridge Mountain region. This area is the wettest area in the southeastern United States, actually in the east. The Pacific Northwest gets the most rain of anywhere in the United States, with parts even down into Oregon being in the pink zone there. So those are our temperate rainforest up there in the Northwest. In our next video, we're going to look at how do we calculate runoff. So there's going to be two types of runoff calculations we're going to focus on. We're going to focus on the rational equation and also Manning's equation. And you might ask yourself, why is calculating runoff important? So we're going to cover that in the next video. But before we go to the next video, I'm going to do a quick review. Okay, so plants produce vapor for the hydro cycle. So what is the vapor called? And that would be transpiration. Alright, next, what provides small streams with base flow during the summer and late fall when precipitation has been light? So where does that water come from that's in these small streams? And the answer is the groundwater. Alright, three agencies in the United States government that are concerned about precipitation. So what are three agencies that actually help monitor precipitation? So the three big ones, I'm glad you asked, right? National Weather Service, which is part of the National Oceanic and Atmospheric Administration, or NOAA, U.S. Army Corps of Engineers, and the U.S. Geologic Survey. Alright, there are a few other ones that probably do, but those are the three big ones. In the eastern United States, where is the most rainfall? So that would be southwest North Carolina, the Blue Ridge Mountain region. What about out west? Out west, the Pacific Northwest, kind of from the northwest Oregon all the way up the Pacific coast up towards Seattle. Alright, so we're going to stop this video here, and we're going to go into the next video on using the rational equation.